Today on Economic Superpower, we are going to be discussing elasticity and its applications. By definition, price elasticity of supply is a measure of how much the quantity supplied of a good responds to a change in the price of that good. The price elasticity of supply depends on the flexibility of sellers to change the amount of the good that they produce. There are 5 key determinants of price elasticity of supply. Number 1. Time period. Supply is usually more elastic in the long run in comparison to the short run. For example, you cannot change the size of factories or productive capacities in a short period of time. Over longer periods, firms can build new factories or close old ones. In the long run, the quantity supplied can respond substantially to price changes. Number 2. Productive capacity. Most businesses in the short run have a finite capacity. This is an upper limit to the amount that they can produce at any one time, determined by the amount of factory inputs that they possess. This depends on the state of the economy. For example, in times of strong economic growth, firms may be operating at full or near to full capacity. There is an increased demand and it may be difficult for them to expand output to meet this new demand, and so the supply may be inelastic. On the other hand, when economic growth is slow, they may have to cut back output, and in this case, if the demand later increased and then prices rose, it may be easier for the firm to expand output more easily, and supply is then said to be more elastic. Number 3. Size of firm industry. Supply may be more elastic in smaller firms or industries than in larger ones. Also, the more firms that there are in an industry, the easier it is to increase the supply. Number 4. Mobility of factors of production. Consider a farmer whose land is devoted to apple trees. A sharp increase in the price of oranges might encourage the farmer to switch use of land from apple trees to orange trees. The mobility of the factor of production land, in this case, is relatively high, and so the supply of oranges may be relatively elastic. Consider another example, a group of highly skilled cardiologists. An increase in the wages of the cardiologists will not mean that the other doctors can switch to take advantage of the higher wages and in turn increase the supply of cardiologists. The mobility of labour to switch between different uses is limited, and so the supply of these specialist cardiologists is relatively inelastic. Number 5. Ease of storing stock or inventory. In some firms, stocks can be built up. This enables these firms to respond more flexibly to changes in price. Price elasticity of supply is said to be quite elastic in these cases. Example, the fresh fruit market is inelastic, whilst we would say that the market of IKEA is quite elastic as stocks can be built up easily. Now we shall discuss computing the price elasticity of supply. Price elasticity of supply is said to be the percentage change in quantity supplied over the percentage change in price. For example, suppose that a 10% increase in the price of boats causes the amount of boats supplied to the market to rise by 15%. We calculate the elasticity of supply as 15 over 10, which is 1.5. And in this example, the elasticity of 1.5 reflects the fact that the quantity supplied moved proportionately 1.5 times as much as the price. The midpoint method. Here, the price elasticity of supply as shown is Q2 minus Q1 divided by Q2 plus Q1 divided by 2, all over P2 minus P1 divided by P2 plus P1 divided by 2. The numerator is the percentage change in quantity supplied, computed using the midpoint method, and the denominator is the percentage change in price, computed by the midpoint method also. For example, suppose that an increase in the price of milk from €2.85 to €3.15 a litre raises the amount that the dairy farmers produces from 90,000 to 110,000 litres per month. Using the midpoint method, we calculate the percentage change as seen on the screen right now. At the end, the price elasticity of supply is 20% divided by 10%, which is equal to 2. In this example, the elasticity of 2 reflects the fact that the quantity supplied moved proportionally twice as much as the price. Now we shall look at some graphs. In example 1, we see a perfectly inelastic supply. In this example, the supply is perfectly inelastic and the supply curve is as seen vertical. Quantity demand is the same regardless of the price. The elasticity is equal to 0. Example number 2. This is an inelastic supply. In this example, the elasticity is less than 1. An increase in price leads to an increase in quantity supplied. Example 3. Unit elasticity supply. Elasticity is equal to 1. An increase in price is equal to an increase in quantity supplied. 20% increase in price leads to an exactly 20% increase in quantity supplied. Example 4. An elastic supply. Elasticity is greater than 1. An increase in price leads to an even higher increase in quantity supplied. Example, a 22% increase in price leads to a 67% increase in quantity supplied. And finally, example number 5. A perfectly elastic supply. And in this case, the elasticity equals infinity. For example, at €5 exactly, producers will supply any quantity, but at any price above this, quantity supplied is infinite, and at any price below this, quantity supplied is zero. Total revenue. Total revenue is the amount received by sellers of a good computed as the price of the good times the quantity sold. Example, price by quantity. Price is equal to €5, quantity is 100, the total revenue is €500. Now we shall discuss how total revenue changes when the price changes, first in an inelastic supply. With an inelastic supply curve, an increase in price leads to an increase in quantity supplied that is proportionately smaller. Therefore, total revenue increases. Here, an increase from €4 to €5 causes quantity supplied to rise from 80 to 100. Therefore, total revenue rises from €320 to €500. Finally, we will discuss how total revenue changes when price changes in an elastic supply. In comparison, with an elastic supply curve, an increase in price leads to an increase in quantity supplied that is proportionately larger. Therefore, the total revenue increases again. An increase in price from €4 to €5 causes quantity supplied to rise from 80 to 150. Therefore, total revenue rises from €320 to €750.
Price elasticity of demand is how much the quantity demanded of a good responds to the change in price. If a good is elastic, then there is a big change in the quantity demanded of a good when there is a change in price, and this means the product is price sensitive. If a good is inelastic, then there is only a small or no change in the quantity demanded when there is a change in price, and this means that the product is price insensitive. In order to calculate this, we divide the percentage change in the quantity demanded by the percentage change in price. Elasticity of demand measures how willing consumers are to stop buying a good when the price of the good rises. There are a number of factors that determine the price elasticity of demand, such as the availability of close substitutes, as goods with close substitutes tend to have a more elastic demand because it's easy for consumers to switch to other goods. For example, if the price of butter were to increase, then the majority of consumers would simply switch to using margarine. However, if the price of eggs were to increase, then consumers would have to continue buying them at this price because there are no close substitutes for eggs. The elasticity of demand of a good also depends on whether it is a luxury or a necessity. Necessities tend to have a very inelastic demand, whereas luxuries have a very elastic demand. For example, gas and electricity have a very inelastic demand, as they are used to heat homes and cook food. If the price of one of these rose, then it is unlikely that people would stop buying them because they are considered a necessity. However, if the price of sailing dinghies increased, then a lot of people would stop buying them and demand would fall substantially. The definition of the market also determines the elasticity of demand. Narrowly defined markets tend to be more elastic than broadly defined markets. This is because it is easier to find close substitutes for a narrowly defined good. For example, food is a very broad category with no good substitute for food in general, whereas ice cream is a narrow category as it is easier to find substitutes for ice cream. Vanilla ice cream is an even narrower category where it is even easier to find substitutes in simply another flavour of ice cream. The higher the proportion of income devoted to the product, the greater the price elasticity. For example, buying a car will take up more income than buying a pizza will. Therefore, if the price of a car rises by 10%, it's going to have a greater effect on demand for cars than a 10% rise in the price of pizza would have on the pizza market. A 10% rise in the price of pizza won't make a huge amount of difference to the price, whereas a 10% rise in the price of a car will be much greater. The time horizon is another determinant of the elasticity of demand. Goods will have a more elastic demand over long time horizons. For example, if the price of petrol rises, it would have a relatively small impact on the demand of petrol in the first few months, with people still needing to get to work and take their children to school. But over several years, the quantity of petrol demanded will fall as people make arrangements to move closer to the city, begin buying more petrol-efficient cars, or start using public transport more frequently. If the elasticity of demand is between 0 and 1, elasticity is said to be inelastic, as the percentage change in quantity demanded is less than the percentage change in price. In the extreme case of zero elasticity, demand is perfectly inelastic, and the demand curve is vertical. This means that regardless of the price, the quantity demanded will remain the same. If the elasticity is greater than 1, it is elastic because the percentage change in quantity demanded is greater than the percentage change in price. If the percentage change in quantity demanded is the same as the percentage change in price, then this is unitary elasticity. When showing the elasticity of demand on a graph, the steeper the demand curve that passes through a given point, the smaller the price elasticity of demand. In some cases, the quantity demanded of a good changes as consumers' income changes. In order to calculate this, you divide the percentage change in quantity demanded by the percentage change in income. Necessities have a very small income elasticity, whereas luxuries have a very large income elasticity. Cross-price elasticity is how the quantity demand of one good changes as the price of another good changes. This is calculated by dividing the percentage change in quantity demanded of good 1 by the percentage change in price of good 2. Whether the cross-price elasticity is positive or negative depends on whether the good is a complement or a substitute.
Now let's have a look at some applications of supply and demand elasticity. One example can be seen if we look at train travel. Train operators know that the demand for rail travel between 6 a.m. and 9 a.m. is higher than during the daytime. At the same time, they also know the commuters have little choice about when they have to arrive at work or school, and that because the train is convenient, it has few substitutes. This means that the price elasticity of demand for train travel in the early morning is relatively low compared to midday. Therefore, train operators can apply this knowledge of elasticity to maximize revenue by charging different prices at these times. Another real-world example of supply and demand elasticity can be seen by looking at farmers' incomes. In particular, let's look at dairy farmers. Advances in technology mean that overall productivity has increased and that each farmer can produce more milk per cow. We would expect this to mean that by increasing the amount of product sold, farmers' incomes would also increase. However, farmers' incomes have actually fallen in recent years, despite the increase in productivity. The question is, why? Well, so far we have been working on the assumption that all other things are equal, but this is not the case. Engel's law tells us that as people's incomes increase, the proportion of their income devoted to food declines. Therefore, the market price of food falls, and thus, farmers' incomes fall similarly. Tell us what you think or ask us a question about elasticity by leaving comments, liking, or subscribing to Economic Superpower. Join us next week for our next video on supply, demand, and government policy. Until then, happy studying!